Hey everyone, welcome back to the College Algebra playlist. In the previous video, we took a look at linear equations, and we showed how to put a linear equation in two variables into slope-intercept form, point-slope form, and standard form. Alright, so in this video, I want to take a look at special types of lines. Namely, I want to look at vertical, horizontal, parallel, and perpendicular lines. Okay, the equations of those types of lines have special properties. All right, so let's dive into it right now. Okay, here we go. We're going to start with vertical lines. All right, here we're asked to find the equation of the line passing through -3, -4, and -3, 2. Okay, so here are the 2 points. Okay, and if we draw a line through those points, we can see that it's a vertical line. Okay? So whenever we find the equation of a line, right, we start with y equals mx plus b, okay, and we try to find m and b, all right? So most of the time we want to put the equations of lines into slope-intercept form, okay? So let's use the slope formula to find m. Okay? We have x1, y1, and x2, y2 right here. Okay, we can plug these values into the slope formula. All right, and we get up top 2 minus -4 in blue. All right, and then on the bottom we get -3 in red minus -3 in green. Okay? So that gives us up top 2 plus 4, and on the bottom we get -3 plus 3. Okay? So look at what we have. It turns out that this is 6 over 0. Okay, we can't divide by 0. All right? That's not allowed in math. All right? So if we get an answer like this, we say that the answer is undefined. All right? So the slope of a vertical line is undefined. Okay? Notice that there's also some weird business happening with b. Okay, if a line is vertical, that means that it's parallel to the y-axis. All right? Which means it will never cross. Okay, so what do we do for b? If this line never crosses the y-axis, we can't assign some value to b, okay, because it doesn't cross. All right? So we need a different equation to represent this line, okay? What I'm going to do next is just plot a couple more points here. All right, notice what's happening with these points. We have -3, -4, -3, -2, -3, 2, and -3, 5. Okay? The x value for every single one of these points is -3. Okay? So, what we can say is that the equation of the vertical line is x equals -3. All right? So that's our answer. And that looks a little goofy at first, right? Usually when we have x equals something, that's going to be the solution to some equation that we solve. All right, but in this context, we're going to say that the equation of a vertical line is given as x equals c, where c is a constant. The slope of a vertical line is undefined, as we showed by using the slope formula. And the x-coordinate of any point on the line is c. Okay, so in our case, on the previous screen, we had c equal to -3. All right, so we have x equals some constant. All right, so what this means is every time you see x equals something, you need to stop and double check with yourself. All right, is this just the value for some variable? Or is this the equation of a vertical line? All right, the problem should make it clear, right? We should always provide context into which one we're looking at. Okay, so this is the equation of a vertical line. All right, next let's talk about horizontal lines. All right, here we're asked to find the equation of the line passing through -3, 2, and 2, 2. Okay? So when I draw my line, this is what it looks like, right? It's a horizontal line. It's parallel to the x-axis, okay? So let's start with y equals mx plus b again. All right? Let's see if we can find values for m and b, okay? To find m, we need to use the slope formula again, all right? So this is what we have. When we plug in the values, we have 2 in black minus 2 in blue, okay? And that's over 2 in red minus negative 3 in green. Okay? So look what happens up top. I have 2 minus 2, which is 0. Okay? On the bottom, it's 2 plus 3. Okay? So 2 minus 2 over 2 plus 3 is 0 over 5. Okay? 0 divided by anything is always just 0. Okay? So the slope of this line is 0. All right? In fact, the slope of any horizontal line is 0. Okay? So what about b? Well, we can see that this line crosses the y-axis at 0, comma 2. Okay? So b is 2. All right? We have both pieces that we need to formulate the equation of the line. All right, so let's see what we get. When we plug in 0 for m, we get y equals 0 times x plus 2. 0 times x is just 0, so we just have y equals 2. Okay? Let's plot a couple more points on this line to see what's happening. All right, here I have negative 5, comma 2, negative 3, comma 2, 2, comma 2, and 5, comma 2. All right? Notice that the y value of every point is equal to 2. Every point on the line has a y coordinate of 2. Okay? So let's say that the equation of this horizontal line is y equals 2. All right, that's our final answer. Okay? The equation of a horizontal line is given as y equals c, where c is a constant. The slope of a horizontal line is 0, and the y coordinate of any point on the line is c. So y equals some constant. Okay, once again, every time we see y equals some constant, right, we need to stop and ask ourselves, what's the context? Right? Is this the equation of a line, or is this just some value for some variable in an equation we're trying to solve? Right? We need to differentiate between the two. Once again, the problem statement should make it clear which context you're looking at. All right. Next, let's talk about parallel lines. Okay? We're going to look at the slopes of two parallel lines, okay? And we're going to see how they compare, all right? So these are my parallel lines, right? They never intersect, and here are some points that they pass through, all right? The slope of this first line up here is rise over run, okay? So it's 1 over 2, all right? And the slope of this line, right, it's also rise over run, right? We go up by 2 and we go over by 4, okay? So this is a visualization of the slope, all right? The slope of the first line, we'll call it M1, is 1 over 2, okay, because it's rise over run, okay? Furthermore, the slope of the second line is going to be 2 over 4, okay? We'll call that slope M2, all right? M2 equals 2 over 4, okay? 2 over 4 reduces to 1/2. All right, so look at what we have. We have M1 equals 1/2 and M2 equals 1/2. Okay? So we have we have M sub 1 equals M sub 2. Okay? And that's how it always works out. All right? Parallel lines never intersect. This means that parallel lines always have the same slope and different y-intercepts. Okay? So for an example, these two lines are parallel because they both have a slope of 2. Remember, if it's in slope-intercept form like this, we can just look at the equation and immediately say what the slope is, right? What the slope and the y-intercept is. Okay? Slope of 2, with different y-intercepts, these lines are parallel. Okay? Next, let's talk about perpendicular lines. Okay? There's also something interesting happening with the slopes of these types of lines. All right? Here I have two perpendicular lines, okay, and they're passing through some points. All right? So let's take a look at the rise over run of this line first. Okay? Let's see what we have. The y values are 2 and 7 halves. Okay, the change in y is 7 halves minus 2. So that's 7 halves minus 4 halves when you get a common denominator, which gives us 3 halves. Okay, so the rise is 3 halves. And look at this, the run is negative 1 because you're going to the left. Or you're starting at negative 2 and you're going to negative 3. All right, that's negative 1. Okay? So that's the rise over run for this line. Okay, and then for this line, we have a rise of 2. Okay, because 13 thirds minus 7 thirds is 6 thirds, right, which simplifies to 2. Okay, the rise is 2, and the run is 3. Okay, because 5 minus 2 is 3. All right. Remember, the rise over run is the change in y over the change in x. Okay. So the slope of the first line is 3 halves over negative 1. Okay, that's rise over run. All right, but that simplifies to negative 3 halves. Okay? And the slope of the second line, we'll call it M2, is 2 over 3. Okay? So look at this. This is pretty interesting. M1 is negative 3 halves. Okay? And M2 is 2 thirds. Okay? If we were to multiply those together, everything would cancel and we would be left with negative 1. Okay? A negative times a positive is a negative. All right? So M1, M2 equals negative 1. All right? So what does that mean? All right? It means that the slopes are opposite reciprocals of one another. Okay? So perpendicular lines form a 90-degree angle. All right, this means that the slopes of perpendicular lines are always opposite reciprocals of one another. Okay? Here's another example. Here I have y equals 5/4 x plus 7. Okay, and then here I have y equals negative 4/5 x plus 3. Okay? The slopes are opposite reciprocals of one another. Okay? Because one is negative and one is positive. Okay, so they're opposite. And they're reciprocals because you're swapping the numerators and the denominators. All right? Okay, great. So now that we've looked at the slopes of parallel lines and perpendicular lines, we can solve some problems. All right? Here we're asked to find the equation of the line parallel to this line passing through the point 3, 5. Okay? So we have the equation of this black line. We're going to use it to find the equation of this blue line passing through the point 3, 5. Okay? So to form the equation of this line, right, we need to know the slope and we need to know the y-intercept. Okay? So we can start by putting this into point slope form, okay? Because we have the slope and we have a point on the line, right? A point on the line is 3, 5. You say, Luke, I don't know what the slope is. You didn't tell us that yet. Well, this line, right, this black line has a slope of negative 5 thirds, all right? And because these lines are parallel, that means that we immediately know what the slope of this line is, all right? It's the same as the black line, all right? It has to be. So m equals negative 5 thirds. Okay? It has the same slope. All right? And then for the point on the line, right, this is x1 comma y1 here, right? I have negative 5 thirds times x minus 3 in green. And on the left-hand side, I have y minus 5 in red. Okay? So when we distribute on the right-hand side, we have negative 5 thirds x plus 5. Okay, negative 5 thirds times negative 3 is positive 5. Okay, because the 3's cancel, and negative times a negative is positive. All right, so we almost have this line in the form that we want. All right, we just need to isolate x to get it there. All right, so we add 5 to both sides, and we get y equals negative 5 thirds x plus 10. All right, so that's my final answer. All right, the equation of this line is in slope-intercept form. And 9 times out of 10, the problems you work on, they're going to ask you to report your final answer in slope-intercept form. All right. So with this problem, it didn't actually ask us to put it in that form. Right, so you could say, hey, Luke, that means that this answer is acceptable right here. And I would agree with that, actually. But just for good practice, right, a good convention is to report the line in slope-intercept form. All right. Let's try one more problem. Okay, here we're asked to find the equation of the line perpendicular to y equals negative 3/4 x plus 5/6 and passing through the point 2, 3. Okay? So this black line, right, we already know what its equation is. All right? We're trying to find the equation of this blue line. Okay? So once again, let's start with point slope form. Okay? We know what x1, y1 is, right? We have a point on the line, and we know what the slope is. Okay? Because we compare it to the slope of this perpendicular line. All right? This slope is negative 3/4. All right? That means that the slope of the blue line is going to be the opposite reciprocal of that. So the opposite will make it positive, and we take the reciprocal, we'll make it 4/3. All right? And here I have x minus 2 in green and y minus 3 in red. Okay, x1, y1 is 2, 3. Okay, great. So now let's isolate y to get this in the form that we want. All right? When we distribute on the right-hand side, we get 4/3 x minus 8/3. Okay, 4/3 times negative 2 is negative 8/3. All right? To isolate y, we add 3 to both sides. All right? And that gives us y equals 4/3 x plus 1/3. Okay, 3 is the same thing as 9/3. Okay, so I have 9/3 minus 8/3. All right, that gives me a positive 1/3. All right. So I'm skipping the work of showing the common denominator process. I hope that's all right. If you were working on this for one of your classes, you would want to show that work. All right. So this is my final answer. Y equals 4/3 x plus 1/3. Okay, this is the equation of the blue line. All right. That does it for this video. Thank you for watching, and like and subscribe.